When we studied graphs in the very first chapter, we defined the notion of a directed graph or a digraph. And of course, a tree is a certain kind of graph, so you can put arrows on the edges of any tree and you get a digraph. There is nothing we need to say in particular about that. But there is a special way that you can direct the edges of the tree. And that brings us to the notion of roots, which is a notion that's important in itself and useful. So the idea is that if you have a tree, something like that, you can choose a vertex that you call a root. So for example, in a family tree, this would be the oldest known ancestor in a family. In a more relevant concept, if you have a pandemic, this is the patient zero of the pandemic, the root of the pandemic or the epidemic. So how do you define this mathematically? Well, a rooted tree is a tree together with the choice of a vertex that is called the root vertex. So any choice of vertex gives me a rooted tree. So if I have my tree here, this is one rooted tree. I could have also chosen any other vertex, say this vertex as my root. So this is one rooted tree, and as a tree they're the same tree, but since I choose different roots, as rooted trees they are different. So these are different rooted trees. And if you have a rooted tree, there is one very natural way to orient the edges. You start from the root and orient the edges away from it. So if we have this tree with this root, circling means I'm choosing this one as a root. So all the edges that are incident to, well, this is a too easy tree. Let's make matters a bit more interesting. So assume this is our tree and this is the root. Now I start from the root and I direct all my edges outwards, away from the tree. Then I go to the next edge that doesn't have an arrow and I direct it also away from the root. And I keep going like that. So this is a very natural way of orienting the edges, and it gives me a directed tree with all the edges going out away from the root. So if this were the spread of an epidemic, then this shows the direction of the spread of the epidemic. So this person gets infected, their closest friends get infected, this friend has more friends and they get infected, and the epidemic spreads in the direction of the arrows. Of course, why am I directing all the edges away from the root? This is a very negative perspective. You could have equally well directed all edges towards the root. It's just a matter of convention. But in many applications, directing it away somehow makes more sense. So this is one way to get a directed graph from a tree. You take a tree, you choose a root, and you direct the edges away from the root.